Hello, everyone. Welcome to this course on installation and commissioning of electromechanical equipment. I am Lu Min from Huadong Power. Today, we will study Chapter 1, Electrical Control of Automatic Punching Equipment, Low Voltage PLC Circuit. We will explore this topic from the following parts. First, let's take a look at the task objectives. We need to understand the input signals acquired from sensors, the training bench operation panel input signals, the PLC to actuator output signals, and the PLC to 4 motor output control signals. 1. Sensor Signal Acquisition Circuit. 1. Sensor Installation Location Diagram. This is the layout of the various sensors installed on the training equipment. As you can see, the sensors are placed at different key locations to monitor changes in various physical quantities, such as temperature, pressure, and position. These sensors act as the eyes of the PLC system, enabling real-time acquisition of information from the external environment. 2. Sensor Transition Wire Panel. This is the schematic diagram of the sensor transition wire panel. Its function is to gather and transition the wires of the sensors, facilitating connection to the PLC input ports. With this panel, we can more conveniently manage and process the sensor signals. 3. Electrical Control Schematic Siemens. This is the electrical control schematic for the Siemens PLC. In this diagram, we can see how the sensor signals are connected to the PLC input ports through the wiring. This is the core part of the entire control system. It is important for you to thoroughly understand this schematic and comprehend the signal transmission paths and control logic. 4. Sensor Wiring Panel. This wiring panel serves as the connection hub between the sensors and the PLC. Each sensor has corresponding wiring terminals, through which the sensor signals can be accurately transmitted to the PLC input ports. 5. Sensor Signal Transmission Process. The signals collected by the sensors are transmitted to the input I port of the PLC through the terminal block XT2. During this process, the signals may undergo necessary processing, such as amplification and filtering, to ensure the quality and stability of the signals. 2. Wiring diagram of the control panel. 1. Introduction to the functions of the control panel. The control panel is equipped with multiple buttons and control elements, including home, pause, start, manual auto switch, X-axis plus, X-axis minus, Y-axis plus, Y-axis minus, and manual debugging mode. These buttons are used to send various operation commands to the PLC to control the operating status of the equipment. 2. Transmission of button signals. The signals from the buttons are also transmitted to the input I port of the PLC through the terminal block XT2. The PLC executes the corresponding control program based on these input signals to achieve automated control of the equipment. 3. PLC Input Interface Allocation Table. This allocation table provides a detailed list of the PLC input port addresses corresponding to each input signal. With this table, we can clearly understand which input port on the PLC each button or sensor signal should be connected to. This is crucial for correctly setting up the control system. 3. Actuator Output Circuit. 1. PLC Output Signal Allocation Table. The PLC Output Signal Allocation Table shows the correspondence between the PLC output ports and the actuators. Each output port is connected to a specific actuator, such as an electromagnet or clutch, to control their actions. 2. Output Signal Transmission Path. The signals output from the PLC are transmitted through the terminal block XT2 to the aviation plug, and then via the transition wire panel to the actuators. During this process, The transmission of the signals must be accurate and reliable to ensure that the actuators can correctly execute the control command from the PLC. 3. Actuator operating principle. When the PLC outputs a control signal, the actuator will perform the corresponding action according to the requirements of the signal. For example, the electromagnet will engage, the clutch will engage, etc. These actions are key elements for the equipment to achieve automated operation. 4. Other PLC output signals. 1. Servo motor control signals. The PLC can output direction and post-trigger signals to control the operation of servo motors. The direction signal determines the rotation direction of the motor, while the frequency and number of post-trigger signals determine the motor's speed and rotation angle. 2. AC motor control signals. For AC motors, the PLC can output speed, pulse, and forward-reverse signals to control their operation. These signals enable precise control of the AC motor to meet various working requirements. 3. Stepper motor control signals. The control of stepper motors also requires the PLC to output speed, pulse, and forward-reverse signals. Each step of the stepper motor is driven by the pulse signals issued by the PLC. By controlling the number and frequency of pulses, the displacement and speed of the stepper motor can be precisely controlled. 5. Summary. That wraps up today's class. By studying the input signals acquired from sensors, control panel input signals, PLC to actuator output signals, and PLC to motor control output signals, I hope you can gain a more comprehensive understanding of low voltage PLC circuits. Lastly, please complete the exercises after class. That's all for this lesson. Thank you for your attention. See you in next class.